I'm Bart, and welcome to the chapter 3. There is a false myth about the impossibility to do smart contracts on Bitcoin. But it's just a myth. Bitcoin protocol uses scripts to do it. To demonstrate you that it's possible, we have a presentation with Xiaohui Liu, founder of the company sCrypt. Enjoy the chapter.
Thanks for the invite, and I'm super excited to share, what sCrypt has been doing. So for people who have not heard about sCrypt, we are the middle layer that empowers developers like you guys, how to easily build apps on top of Bitcoin. Okay. So, we have a lot of features, but I hope I can give you some highlights. And then, I want this to be interactive. So anytime you have questions or comments, just feel free to interrupt, and we can talk about it. Okay, thanks. So, sCrypt, how does it come from? Okay, where does it come from? Right? So, it all comes from this original code, that's put by the creator of Bitcoin, Satoshi, basically says, for Bitcoin, it's not only for payment, it's just one type of transactions. So he put this feature in, it's called the Bitcoin script inside Bitcoin since day one, because he wants to, people have all kinds of transaction types. It's escrow or multi-sig, any kind of things you can think of. That's so that you can program Bitcoin. So that's what we call it smart contracts. Okay, but back in the days, he called different type of transactions. Okay, so it's not only for peer-to-peer payment. That's just you think about that's only the first step. Okay, so a lot of people will ask, when I talk about use Bitcoin as a developer platform. What? So the number one question usually I get is, hey, why do you choose build applications on top of Bitcoin? Why not something like, Ethereum or let's say Solana or whatever the latest blockchain is? Okay, so here's the high level review of why we want to do Bitcoin. First of all, it has a capability. It has the capability since day one, actually. So I just showed you the original quote from the inventor of Bitcoin. So Bitcoin, when it first launched, even in 2009, it came with this feature, we call Bitcoin script, or sometimes I call it, it has this built-in virtual machine. I call it a Bitcoin virtual machine. Versus, you can think of another type of popular virtual machines, which is Ethereum or EVM compatible ones. So like, Tron and a lot of other blockchains. So if you compare them side by side, you can see it has a lot of advantages. The foremost difference is scalability. Okay, so because of the fundamental design, Bitcoin, your developers here, you heard about the so-called UTXO model versus, Ethereum's account model. So because of the UTXO model, for people who have not heard about UTXO, basically is the unspent transaction output. Okay, so because of this model, it enables the so-called horizontal scaling. What that means is, if you want to process more transactions, you simply add more machines or more threads, whatever you call it. Okay, so that's how all the internet services scale today. For example, Zoom we're using today, or Google or Facebook or Twitter, whatever you think of, it's all use this model. Okay, because at the bottom of this is because the transactions, they're independent from each other. It's like a electronic cash, right? If I have $5 bills and $10 bills, they're separate, they're independent. So that's why I can process them in parallel. Okay. So as a result, we can see on Bitcoin, of course, we're in this conference, when I say Bitcoin, it's always meaning the original Bitcoin, the Bitcoin SV. Okay. So you can see, the transactions, it's a few thousands of transactions per second. And of course, we're always looking forward to the next software terminal, which supposed to bring us close to, if not 1 million transactions per second. Versus, let's say, Ethereum, which is, since its inception, I think maybe 8 years ago, it only can transaction of, about 15 transactions per second. It has stayed that way since its beginning. Versus Bitcoin, we have seen, after we increase the block size, it's increased from 1 megabyte, then to 32 to 256, and today to 4 gigabytes. It has scaled exponentially. Okay, so that's the number one reason, because we think we choose to build all the apps on top of Bitcoin because it's the only chain we can see that has unbounded scalability. Okay, it doesn't only capped at 1 million transactions or 5 million. There's no upper bound to it. Okay, so how does then, after hopefully give you some idea, why do you want to build on top of Bitcoin? And then I'm going to give you some, what does the landscape looks like today? What has sCrypt been delivering? So we built, you can think of, for people who have heard about Ethereum and also developing Ethereum, so you can think of they have a tech stack. That's all the tools and infrastructure, including all the program languages, framework, libraries, ID, support, wallet. That's what they have. And sCrypt, I think we built, you can think about, is a parallel universe where you can think of everything that enables programmers to easily build Ethereum. You have the more powerful, actually a lot of times much easier, tools on our side to build. Most of these tools are built on, by sCrypt in-house, but we also use a lot of, third-party service such as what's on chain. Okay, so this is what a side-by-side comparison. So whatever they have, actually we have, and I'm going to show you why actually it works even better than our competitors. Okay. So before I even dive into the smart contract and maybe tokens later, I'm going to talk about the high level. What is Bitcoin smart contract looks like? Okay. So as we all know, Bitcoin uses this so-called UTXO model. So basically, as I draw here, we have two transactions. On the left, I color it as input, and on the right, you have the output. So in the output, that's where the Bitcoins are. So every Bitcoin, every UTXO in this model, you can think of that's a lock, placed on top of it, because it's needed for access control, right? You don't want anybody to spend your Bitcoin or vice versa, right? Because otherwise, then the whole payment, the whole consensus breaks down. If anybody can spend anybody else's Bitcoin, then it's not going to work, obviously, right? So this lock, usually you have this lock, and then in the input, you have to provide the right key matching the lock, so you can open it and then spend the Bitcoin within it. Okay, so that's I'd say the most popular type of transactions today is using so-called private key, right? So you have some coin locking some Bitcoin address, a public key, and then you got to hold up the secret private key so that you can produce a valid signature. But as I said, this key it can take arbitrary form. So this is just one popular form, which we call it pay to public hash. It just says, hey, you need the private key to produce the signature. So this is what for the lock, you can think about it as a function, a mathematical function, more versus let's say function in a computer programming language is more similar to like a function. For example, you can do a square root, or you can do cubic, all the mathematical function. And this key is, you can think about it as a secret, or some terminology is called a weak list. So if you evaluate this function over the key x, if it's true, that means the key is correct, and then that you can open it. So the key message here is, this function, usually a lot of times in today's use case is just signature verification. but it can be, actually it can be arbitrary computation. So for example, it can be a hash lock. You can say, hey, you can only, if you can produce the right pre-image, a hash into this given value, then you can unlock. Or you can be some, let's say you are solving some mathematical equation. It can be two variables, quadratic, whatever it is. So this function actually, using terminology called, actually it can be so-called Turing complete. You can encode arbitrary computation. So that means in Bitcoin smart contract, you can do any kind of smart contract any other blockchains can do, or any computers can run. Okay, so this is very different from a lot of other, so-called the focus of Bitcoin think. For example, BTC, they think the Bitcoin smart contract, even you can do a little bit, but you cannot do much. Actually, here, so on our blockchain, actually you can do arbitrarily complex smart contracts. That's no problem, and we have demonstrated. Again and again, you can do all kinds of things that's previously thought it was impossible. So let's dive into it. I think this is a high level and more focused on the theoretical side of things. And this is like more like a developer workshop. So I want to get a little bit of a hands-on experience. What does you practice? What does the Bitcoin smart contract look like? Okay, so this is you can think about the hello world of sCrypt Bitcoin smart contract look like. So for people, so I want to just quickly ask, okay, how many people here knows JavaScript? Get a raise of hand or just shout out. JavaScript, anyone?
Maybe 10, 12 people here. JavaScript.
Okay, sounds good. Okay, any so for people who have already know JavaScript, I assume you already have, I think to a large extent, you are more or less familiar already with TypeScript. So TypeScript is pretty much just JavaScript, with optional types. Okay, so sCrypt is this is very different from if you're developing a lot of other blockchains, such as Ethereum, Solana, or whatever the latest. You have to learn some new programming language, and which is kind of like a niche thing. Even though we think the Web3 is popular, but if you look at all the developers, even for Ethereum, when they do the survey, they find out Solidity is about, around 20,000 versus TypeScript or JavaScript is more than 20 million people. So that's why we choose, this is our second version actually. So the first version, we also have our standalone language called sCrypt. And later on, we found out, it has very steep, learning curve. So that's why we have the latest version. We built this actually as a, so-called domain-specific language that's based on TypeScript. So it's a subset of TypeScript. So the idea is developers, they can come here, since they probably already know JavaScript, or they can easily learn TypeScript. So they don't have to learn they can use this so-called, Web2, mainstream programming language instead of learning something new to program, Bitcoin apps. So for people who have seen any kind of like object-oriented programs, such as TypeScript, this should look, I think it should be straightforward. So what does this smart contract do? Is that actually, what I called the hash lock before. So basically you put a hash in the UTXO, and how to unlock this UTXO, you have to give us the pre-image that can hashes, after hashing equals to the, the hash value you put in advance. Okay, so, this class I call it hello world. Maybe you should call it hash lock. Anyway, so you can have, that's, I just highlight a few things that's, which is sCrypt specific. For example, you have to extend from our base class. Every smart contract you write with our framework, you have to extend from the smart contract base class, and then you have properties. we have a decorators property. Let's say this is a SHA-256 hash, and of course constructor, there's nothing special. And then you also have this decorator. Basically, how do you want to call this contract? You have this method decorator, and this is a function, and this is where the X, if you still remember, the function you can think about is just the log here, and the function arguments that you pass in when you try to unlock it, that's the X. So if you're coming back, this message, this is the X in that diagram, and this unlock you can think about that's where the function is encoded. So what this function does is very easy. Actually, you take the X, the message passing argument, you hash it and check if it's what is the same value as you expected before. And this assert basically means, hey, it's like any other assertion in a lot of programming language. You have to make sure this got to be evaluated to true. Otherwise, this whole thing fails. Okay. So if you have a function, all the assertions pass, that means you have successfully unlocked, and you can spend the bitcoins within it. Okay. So this is a hash log hello world example. I think let me show another example, which is probably more familiar to people here. So-called pay to public hash. So this is actually on a high level. What happens when you if you have some bitcoins under your address, when you spend it, this is what happens. Okay. So again, how do you write this in a so-called smart contract? The lock using sCrypt. If you use sCrypt, okay. So usually when people say it's in script, okay. The problem with script is it's a low level language. It's like assembly, and I don't know. There are many people who was comfortable with writing assembly today. We always use some kind of a high level language like sCrypt or Java or Go or whatever that compiles down to the low level, bytecode or opcode level. So it's the same thing here. You can write the pay to public hash using raw script, but it's just very difficult, and very few people know how to write such programs. So that's why the sCrypt smart contract can be play. So if you look at this contract, it's very simple. So you have the address. As we all know here, it's just hash of a public key. So when you try to unlock it, you pass two things, right? One is a signature, the other is public key. So how do you check whether you own this address? Okay, you check two things. As again, I hope this is readable. So you hash the public key, make sure this is equal to address, of course. And secondly, you make sure the signature matches the public key, meaning you own the corresponding private key. Okay, so that's actually what happens under the hood when you try to spend bitcoins, under your address. Okay, you do these two checks, but hopefully this is much simpler than when you try to read some Bitcoin script. Okay, so one benefit of I just showed you how to write smart contracts. Okay, and then you don't have to learn new language. You can use all your favorite tools. Right? For example, you have IDE, and also maybe you want to use, of course, it's a smart contract. It deals with real bitcoins, real value. You want to make sure your contract's rock solid before you deploy it to production, right? So, for that, we can do a lot of tests. And because it's just TypeScript, JavaScript, so you can use all your favorite, testing frameworks. For example, here I use Mocha. You can use Jest or Jasmine, whatever your favorite testing framework. Because again, I want to emphasize this again, because it's just TypeScript, JavaScript. You can use all your favorite libraries and tools to develop the contract. Okay, you don't have to use, some new programming languages or some new tools. You can just reuse your Web 2, so-called Web 2 tool set. You can just use the same thing. Okay. So you can do the testing. You can also debug, in two ways. First, of course, a lot of if it's not too complex, hopefully you can just print out to the console, right? You can use console logs to print out the values to your console to help you debug. Or if it's more, challenging debugging, it's very difficult, you can always use your favorite, TypeScript debugger. Because again and again, it's just TypeScript, so you can use all the favorite tools. So for here, I use Visual Studio Code. It comes with TypeScript debugger by default out of the box. You don't have to install any other extension. It just comes out of the box. So you can, it's just simply TypeScript. So you can set up breakpoints. You can step in. You can step out. You can watch variables, call stacks. You can use the console. You can use everything that you typically do in your day-to-day programming life. You can just reuse all these tools here. You don't have to use anything new. If you don't like Visual Studio Code, go to your favorite other IDEs. That's all. Everything is fine. Okay, it will just work as usual. Nothing changes. Okay. So of course, nothing can be more powerful than libraries, right? Because this is just TypeScript, so you can reuse the node npm to manage all your packages and dependencies. There's nothing atypical. Okay, you can, for example, if you want to use other people's libraries, you can just npm install. If you want to publish your library so other people can use, or you can use it in other projects of your own, you can always publish to npm. This is the same workflow as you do with Web 2 programming. Okay. So you have the full stack. You can, we are not the easiest way you can program Bitcoin smart contract. I would even argue it's the easiest way to program contracts in the whole blockchain space, because there's no easier solution. Okay, so this is the easiest because you don't have to know anything about, let's say, so-called Web3 or Bitcoin. You can just use the Web2 tools you already have. Okay, just to give you a sense, how easy this is. So for example, we showed the Hello World example before. But what if you want to, deploy this? Basically means, lock up some Bitcoin within this contract and broadcast to the network, and then later on try to spend from it. It's simply just one line. You just call, once you initiate it, instantiate it, you have this instance represent this specific contracts, and then you can just call deploy, and then you just put, hey, how many Bitcoins I want to put, lock into it. So you just one line is assembles the transaction and broadcast it. It's just one line, you deploy it. Okay. So when you want to unlock it, when you want to so-called call this contract, the same thing. You just do it one line. If you remember the function name is called unlock. So you just call on this same instance, you just .methods.unlock and pass in the right message. So you can unlock this also, assemble the transaction, the second transaction, spending from the previous transaction, UTXO, and then broadcast it to the miners and have it accepted. So everything you can think of is just one or two lines of code. I don't think you can make it even easier. Okay. So this is just a high level idea I want to give. You can use sCrypt to program Bitcoin smart contract pretty easily. Okay. So the next I want to say, hey, you talk about all this, but what kind of things people already, what kind of some cool smart contracts or interesting smart contract people already built? Okay. So I want to show you a few examples, but before even diving into examples, as I said earlier, you can program arbitrary, so-called Turing completeness. It means you can do any kind of a smart contract using this framework. There's nothing that other blockchains can do that you cannot do here. Okay, so it's just and it's more efficient, right? Orders of magnitude. So it's very hard to, after you have this, it's very hard to use any other blockchain in terms of smart contracts. Okay. So the first one, I think this is one of my favorite. It's called cross-chain atomic swap. Okay. Let's say, we have Bitcoin, BSV, and somebody has a BTC. And what if we want to exchange? Okay, we want to trade. So usually without, smart contract, what do you do? Let's say Alice has BSV and Bob has BTC. So usually what happens is, let's say if they want to do this trade peer-to-peer, okay. So if Alice gives Bob her BSV first, Bob may run away, right? Vice versa. If Bob gives Alice his BTC, Alice may run away, right? So it's not secure, this trade. So what happens usually is they have trust some kind of a third party, right? For example, exchange, or some kind of escrow, and But with smart contract, thanks to smart contract, you can do this actually so-called atomically, meaning the exchange either happens, so both people are happy, or it doesn't happen at all. There's no case. Only coins move one direction. Okay, so you can use actually, so for here we publish all the detailed protocols you have to go through and all the running code. So the idea is using some kind of like a hash puzzle we just used before, hash lock. So if you unlock on one chain, you reveal the same pre-image that's on the other chain. So you can always make sure if one ever takes the other's Bitcoin, you must reveal the pre-image so the other guy can take the Bitcoin on another chain with the same pre-image. Okay. So the idea, I just want, it's simple. Okay. So if you want to know more about details, always you can go to our website and go to our blog. For all this, we publish the open source and free contract code you can reuse. So this is one example. And the other one, I think it is also one of my favorite. So what does this do is you can turn, either iPhone or Android, any type of smart contracts into hardware wallet. What does that mean? So for a lot of people, if it's a large amount, they put the Bitcoins in so-called some kind of a, hard wallet I show on the right, ledger, Trezor, whatever it is. Okay. But the problem is you have to buy this extra hardware, right? What if I tell you, you can use your phone to store your Bitcoin with the same security level? So, technically, this is a little bit of involves a little bit of cryptography. Basically means, in your phone, there's also like a special hardware. It's as secure as your hardware wallet, meaning the private key is never exposed. It's called secure enclave in iOS, iPhone, or Android. So this thing, you can think about it comes with its own hardware wallet. But the problem is you use some kind of a different signature scheme than the typical signature we use in Bitcoin. Okay, so you cannot just easily, for example, the Bitcoin has this mechanism to check signature, right? So you cannot just use that. If you produce a signature in that hardware wallet, in that secure enclave of your phone, it's not compatible with the Bitcoin because they use different, you can think of it, they use different signature scheme. But because the contract's programmable, so what you can do instead is, hey, even though the checksum, default checksum doesn't match whatever the phone is producing, the signature, I can program my smart contract, right, such that it can validate the signature coming from my iPhone or Android. Okay, so you lock your Bitcoins in that contract, and this contract just, again, it just checks signature. The only thing different is the signature is not the check signature is not the default signature algorithm. It's checking against the iPhone signature. So that way, in this way, you can securely store the Bitcoins in your phone. Okay, you don't have to buy another, Trezor or Ledger. You can just use your phone as your hardware wallet. Okay, so this is another use case. So this is more like on the practical side of things, and then on the, hopefully this is technically more interesting. We have this big category which I call the outsourced computation. Right? For example, let's say Alice, she's very interested in Sudoku. She's always trying to solve all kinds of Sudoku puzzles on on her commute, or even on vacation for whatever reason. And then one day she comes out with this Sudoku puzzle. She spent like half a day on it, but still she cannot figure it out. Okay, but what if, let's say, hey, she can even publish a public bounty, right? Say, hey, anybody, if you can help me solve this Sudoku puzzle, I'm going to pay you, let's say, 1 Bitcoin. Okay. So again, this has the same problem with the atomic swap. So if Bob gives Alice the solution first, Alice may not pay him, right? Vice versa. If Alice sends Bob the Bitcoin first, Bob may not even have the solution, or even he has a solution, he may choose not to tell Alice. Right? So we always have this problem. How to make this? You can think about atomic. So thankfully, Alice can use smart contract to solve this problem elegantly. So what she does, simply she locked up the 1 Bitcoin into a smart contract, and this smart contract is also very simple. It just checks if there's any solution comes in, it just validates the Sudoku rules, right? For example, all the rows, unique from 1 to 9, and all the columns are good, the subgrid is good, right? So she can encode all this check within the contract. So then this is atomic, right? Only way Bob can take the money is to provide a valid solution, right? There's no cheating going on, right? So you can outsource this kind of computation. But of course, as I said earlier, this function can be arbitrary, right? I just here says, oh, it's Sudoku. Or it can be, in this case, it can be a logistic issue. For example, you can solve the, finding a short path, right? Let's say you are the delivery man, you want to deliver all these packages to this households. You are saying, hey, help me compute a route that travels all these ones with, let's say, total distance less than 10 kilometers or whatever. You can solve all kinds of optimization problems. And also for people who have learned, especially nowadays, it's very popular, the AI machine learning. They even have this Kaggle. This is for people who have not heard about this. So this is a website that hosts machine learning competitions. Basically, for people who want to solve some machine learning program, they can put a bounty there, and whoever has the best solution, they can take the bounty. Okay, it can be up to $1 million. Okay, so you can do this without go to some centralized website. You can do this purely on chain. Okay, you just publish your computation you want to find the solution for. You just check the solution. And if anybody who's giving you the right solution, they can take the Bitcoins. Okay. So this is another use case. And another, the last use case I want to show is, games. So a lot of people, they want to put games on the blockchain, for a lot of reasons. I'm not going to go to details. Okay. For example, nobody can cheat. It's transparent. And there's no central company that can, rug pull or, change the rules while it's in play. Okay. For a lot of reasons. Anyway, I'm going to not dive into the detailed reasons. But one difficulty they have is, for there are two types of games. One is so-called complete information. Think about we're in chess, right? You know my moves, I know your moves, everything is open in the public. Okay. But what if I want to play something like a poker? Is that possible? Because poker is different because I don't know what's in your hands, you don't know mine, and we don't know what's under the deck, right? Because if you know, that's not poker anymore, right? So for example, here I show two other examples, Battleship, and the other one is more, this one runs on Ethereum. It's based on a sci-fi novel with the same name called Dark Forest. So, all these games, they share the feature. You don't know everything, right? The so-called hidden information or partial information game. All the most popular games of today, right? World of Warcraft, Civilization, it's because you don't know what's going on in other parts of the game, or you don't know you may not know everything about, what every other player had information, right? So that's what makes it fun. So actually with some kind of a good cryptography called zero knowledge proof. Okay. So zero knowledge proof, you can think about as the most complicated smart contract out there. I'm not talking about Bitcoin. In the whole blockchain space, this is the most advanced, the most complex smart contract because it takes a lot of computation. And, so that's what I also want to mention. We implement zero knowledge proof in Bitcoin. And this is the most complex type of smart contract ever in the whole blockchain space. So we're not only claim we can do arbitrarily complex smart contract, we have done it again and again. Actually, because it's more scalable, it's much cheaper than, let's say, Ethereum. It's at least 1,000 times cheaper. Okay, so because of this, you can have hidden information game. So you can migrate, real games on top of Bitcoin if you want. Okay. So that's, the part where I showed you, the contract side of things. So next, I want to show, highlight what other things that sCrypt can provide that you may leverage in your apps when you try to build apps. Okay. So here's a list of features we have. As I said earlier, we want to become, the developer platform that, Bitcoin developers, the go-to, the primary one, so people can go there, one stop. They don't have to go to any other website. They can learn everything they need to build, so-called dApps on top of Bitcoin. So for that, we provide a lot of tools and infrastructure such as SDK, APIs. We also have, of course, I just spent 40 minutes talking about smart contract. Okay, that's how we started, but now we are adding more service on top of it because, if you only have standalone smart contract, there's still a lot of other missing pieces to build a full stack app. Right? So that's why we add authentication, SDK APIs to allows you to, read from the chain, write to the chain, listen to the events, even have webhook or WebSocket, everything you can think of as a typical, full stack app. We got you covered. We also have, I'm going to show you later, dashboard, and also pretty recently, we add also, tokens. So you can find out all this on our website. So tokens is the latest, biggest upgrade we have since we launched smart contract. And for tokens, we, for us, we can, in theory, we can support arbitrary token protocols on Bitcoin, but at the first starting point, we support one set ordinals. Okay. For a lot of reasons, I think we have a detailed blog explaining why we made this choice to support one set ordinals at the beginning. So, but you can read about it on our blog. But simply, we have, ordinals. It has NFTs, non-fungible tokens, but we can also have the fungible tokens, which, called the BSV 20 standard. So the best thing about ordinals is it's fully compatible with sCrypt. So think about, before these tokens, sCrypt can only control, limits, lock, asset, type of asset is Bitcoin, Satoshis. But now, because the tokens, Ordinals tokens is compatible with sCrypt, so you can tokenize anything you want. And then how do you control this new type of tokenized assets? You can use sCrypt as if you are control the transfer, the access of Bitcoins. So not only we have this capability, we also have released the SDK. You can easily integrate. So you don't have to know anything about Ordinals or even sCrypt. So you can just use this. Sorry, you only have to know sCrypt. You don't have to know anything specific about the underlying Ordinals protocol. So you can easily tokenize assets and then use, so-called smart contract to control how these assets move. Okay. So for example, you can do atomic swap. You can even lock your Ordinals in your phone. As we thought, you can use all the previous examples I have mentioned and apply it not to Bitcoin, but to Ordinal tokens. Okay. So again, we support a lot of existing so-called Web2 frameworks, web frameworks. Here we support all of this. With the most popular, I think, top 5 front-end frameworks. React, Vue, Angular, whatever, Next.js, whatever your favorite is, probably here. If it's there, just let us know. Or because it's open source, you can even add your own if you want. Okay. So that's, again, I think I briefly talked about this before. So this gives you a sense of, why we choose the TypeScript, JavaScript framework. Because if you look at Web3, there's a number of developers who knows how to build code in Web3. This is some other more mainstream programming languages. So if you look at JavaScript, it's about 1,000 times bigger. So that means any Web2 developer today, if they want to build with our tools, they already have all the tools, and the only thing is they have to learn this new library called sCrypt. But it's not different than any other library they want to use, right? You just read the docs and you're ready to go. Okay. So I talk about our website homepage, script.io. Everything we have is listed there. For example, this documentation, hopefully it's very detailed. Everything you need should be there. You can also search through it. So, tokens, smart contract, everything listed from here. You can also, because we have have API services, so you can also, go to sign up at our website and go to a dashboard. You can get the API keys. We support both mainnet and testnet. Once you have the keys, you don't have to run a node. You don't have to understand which miner to talk to, which endpoints to broadcast to, whether it's let's say it's what's on chain or Tau, you are using ARC, or you are using the node software itself, or miner API. You don't have to know anything about this. So it's all wrapped. We build abstraction. So you don't have to know anything specific. We hide all the blockchain part, so you don't have to know. So that give you a lot. That I think it reduced the learning curve quite a bit. You don't have to learn all the blockchain specific. You don't have to. But of course, if you want to know what's going on, you can read all about this. But if you just build a game or just a website using Bitcoin smart contract and tokens, you don't have to. So we periodically hold hackathons, and a lot of people they just come here for the first time, and they build very cool apps. They are not experienced so-called Bitcoin or even Web3 developers. So this is, if you have not tried it yet, just check it out. Okay. So not only we have all the tools, but also regularly we push out educational materials. For example, here we have sCrypt Academy. So what this is an interactive course. So we have the description, and also we have homework left to do, tasks, and we show each step step by step. We also show, you have to get the right step, finish the code, make sure it works before you can advance to the next step. So here, you go to this website, it's free, and you don't have to know any prior knowledge about sCrypt or Bitcoin. If you walk through this step by step, within a day, I think you can even build your own full stack runnable, so-called Bitcoin apps. For example, I showed the tic-tac-toe here. I also showed you even how do you build the battleship game with zero-knowledge tools we have. So with that, I think that's hopefully give you some idea of what we do at sCrypt. So again, everything you can find out at this website. So with that, I pause here and let me know if you have any questions. Thank you for your time.
Hi, thanks for your presentation. I'm Thomas, and would like to know. I saw on the demo contract on your presentation, there was like a connect function that connects to this default signer. Is that it
Yes.
was a mimic, or it's also, or it's in the framework to then connect directly to the signer? Yeah, that part.
Yeah. Yeah, good catch. So this signer is an abstraction. I think I intentionally skip this because it may take a while to explain. So basically, this signer is an abstraction of it's a wallet. Okay, so basically, it's the wallet.
Okay.
So because usually, right, when you're testing, you may you can have a simple wallet. We call it the test wallet. You can put your private key there, right? But in production, usually you don't want to, ask the user to provide the private key, right? Usually you connect your app with your wallet. For example, here the Panda wallet, Sensible wallet. So this is abstraction.
Okay. Thank you. I got it.
Okay, good catch. Yes. So the reason we use this signer approach is then it's very easy to switch from a develop environment to production, right? When you are developing locally, you can use a private key wallet. But later on, when you push it to production, you can simply switch out the signer to whatever wallet, your favorite wallet you want to connect to. For example, Sensely wallet, Panda wallet, Tau also has a wallet that's also compatible with us, and the Dot wallet. So right now we have 4, but it's very easy to extend, add this support. If a wallet wants to become a signer of sCrypt, they just have to implement the interface. So then they're compatible with us. So it's a good abstraction.
Great.
Thank
Thanks.
you.
Thanks for clearing.
Hi, Xiaohui. Thanks for the presentation. My question is about the parallelism between this ecosystem you have built and Ethereum. We are all seeing that it's important to provide developers to all the tools, and also the final user the tools to verify that the smart contracts are going to do what it's supposed to do. In Ethereum, there is a kind of need of audit the code. When you put a smart contract compiled into the Bitcoin blockchain, there's no way to audit this code and to verify what it's supposed to do. How do you think is possible to provide the final users or the receiver of UTXO with a smart contract in the login screen? How is possible to provide this capacity of verify the content of the script?
Yeah, excellent question. I think let me show you a web page here. So again, go to our website, and if you click Docs, so yeah, great. Yeah, if we have a section here, I think this is what you're asking. How do you verify, right? So because on the blockchain, okay, hopefully this is address your concern. Yeah, it's a very good question. It's a question should be asked by everybody who interact with any kind of smart contract. So how do I know this smart contract is doing what it claims to do, right? Because on chain, you can only look at the script, or it's like Ethereum world, right? So we are not doing anything differently than the Ethereum world. So in the Ethereum world, they're also doing the same thing. So, in the blockchain, you can only look at the opcode, right? So-called, it's like a assembly, okay? So in Ethereum world, you have to go to website, for example, the Block Explorer. You have to upload your source code there. And then what this website does is you compile this contract and compare with literally byte by byte with whatever that's in that contract on chain. So if only these two matches, that means this is so you have to upload the source code, high level language. In their case, is the Solidity. In our case, is sCrypt. So this website for us is what's on chain. For them is, I think, Etherscan or maybe some other website. You have to upload your source code. So what this website does is it just literally compile it and compare it, byte by byte with whatever is in on the blockchain. So if only this matches, then I know this contract is what that's a high level code, right? So that's a step one. You make sure, this deploy contract is whatever you claim that the sCrypt contract is. The second part is, of course, you have to audit it if you want to actually make sure. But then it's like any other programming language. You have to find, if you really want this to rock solid, because you are dealing with a lot of users' funds, it's a great idea to audit this. So two steps. One is to verify, the source code is matches the on-chain footprint. The second is one, optional second step is, if you want to make sure it's ultimately secure, you have to audit it. Yes. So this process is not different from, say, Ethereum. Does this make sense?
Yeah, thank you for the answer. I mean, when the contract has been published by a third, and you don't know the source code, it would be a good idea to have a place to upload the source code, to freeze it for the future to be audited as well. Of course, if you have the source code, you can validate it in this way. But for the future, maybe in the up return of the transaction, maybe you can upload the code as well or something like that. I don't know how to freeze the code to be verified in the future. What I seen right now?
So, okay, first I'll explain what's happening here, and then let me know if it doesn't answer your question. So we have two ways to verify it. One is through the UI. We have a What's on Chain plugin. You can go there and upload your source code. So this is very similar to like Ethereum world. You can go to Etherscan and upload your source code there. And even you are a third party, right? So before I start interacting with your contract, I need to make sure this is the contract you claim you have deployed, right? So you have the one, whoever deployed this contract has a very strong incentive to publish the source code, because otherwise, people cannot, third parties, they don't know, right? They don't know what's happening. They're not comfortable interacting with the contract. It's like the Ethereum world. Before I send my Ether or ERC20 tokens to this contract, I need to make sure this contract is what it's supposed to be, right? So that's one way you can use the UI from the UI. But a lot of time, right, it's just a little bit, you can do this, but it's a little bit cumbersome, right? You have to go to what's on chain, you have to do it. What if you change your code? It's not, maybe at the final stage you can do this, but what if you are changing the code all the time, right? You are still developing. So that's why we also integrated with our CRI tool. With command line, you can basically automate this process. You can say, hey, I deploy this, but then I want to, validate this. You can say, hey, this is my contract. basically this is whatever we use a hash of the script as like a signature. So we want to make sure, hey, is this contract really hashes to this? Because on chain you can find about this. So this basically is automate whatever you are doing on the front end UI. So you can do it with this is the CRI, so you can automate it. You can even put this in your CI CD. You can do all this without going to the front end. Does this help your question or?
Yeah, a lot of possibilities. Thank you. We are discovering this in this meeting. At least I am discovering the plugins function in what was on chain, and there's a lot of the things to research. Thank you.
Okay, yeah, great.
Hi, this is Jamie XBT. First of all, you are the boss. Yeah, we were discussing at the event about the different tokenization protocols that BSV that you can choose or you can pick for your use case. And we were talking previously about the stable coins. I don't know if you can show us in an easy way or in a short way how we can build fiat tokens with sCrypt.
So I look at it from two angles. First is technical. The second is legal. Okay, I think this about stablecoin. I think it's the more challenging part, at least to me, is more on the legal side of things. How do we make sure it's compliant and also make sure it's fully backed. I think it's less about the technology. For example, you can use ordinals. You can use some round tokens to represent it, no problem. I think it's I don't have a good. I think it's not sCrypt. For tokens, whatever tokens you choose. So we choose to support ordinals first because it's the one that's compatible with the sCrypt. Because on a high level, one set of the ordinals they don't use the script part. They don't have logic. It's just color the Satoshi part. So you can control how the Satoshi works still with the full script. So that's why we prefer, at least if you want to use sCrypt with any kind of tokens, you got to use ordinals for now. Okay, maybe later on we can choose some other tokens, but for me, I'm a little bit biased. I would recommend use ordinals, and this is one reason it's compatible. Second is it's got a lot of support in the community, right? You got some developer community. You also have a bunch of wallets that also support it. Handcash, Panda, Sensely, Dot Wallet, Tau Wallet. It's more popular, I think, and also it's also known outside of Bitcoin SV space, right? Even BTC, BCH, even Dogecoin, LiteCoin, they have their own ordinals. So yeah, for me, I'm a little biased, but I would recommend if you only ask me about the tech side of stable coins, I would recommend ordinals, but I'm not sure about all the legal compliance side of
compliance and
things.
legal is more tricky. Yeah, it's okay. That makes more sense to have more interoperability with the ordinals too.
Yeah, I think this is the most interoperable one out there. So if you on the technical side, it's the most interoperable standard. Yeah, I think that I don't know about the legal or the compliance side, but for technical perspective,
no worry for that.
I would strongly recommend it. Yes. Is that a plan to? Is it a stable euro or is that?
Yeah, we are planning something.
Okay.
Yeah, it's just another possibility to have all the full picture about all the possibilities and pros and cons.
Yeah, good luck on the stable coins.
When you talk about also supporting one-shot ordinals and in the way that is compatible with sCrypt, will that be also true with Stas token? Is it easy to integrate with sCrypt?
Okay, so let me open this. Open something. So the short answer is unfortunately not. Okay. Let's see.
Okay.
So I'm going to briefly cover why. And let's say ordinals. Because I said at the very beginning, so the ordinals is very compatible with us out of the box, because if you think about the UTXO, right, it has two parts. I think that's what I'm talking about. That's why we have an article to talk about why we, at least initially support ordinals. We may choose to add other tokens like stars or run or whatever that's coming. So the reason is number one reason is, if you look at that, we talk about the UTXO model, right? The UTXO has mostly two parts. One is the Satoshi part, right? The amount, the value part. The second is the script part. So sCrypt, you can think about it's in the script part. And the ordinal, the token is in the set Satoshi part. So that's what makes these two, can be combined or composed in arbitrary way. For example, you have some ordinals, you can put it in a hash lock, you can put it in a pay to public hash, you can put it in an atomic swap, you can put it in a trade, anything you can do, okay? Because these two are orthogonal, independent. So that's why you can combine them arbitrarily. Versus something like a stars. Stars is also, it's not only in the Satoshi part, but it's also in the script. It has its own script. So that brings a problem. You cannot combine two scripts, right? Because they may work separately, but you put them together, they may evaluate to false. So that's why, at least for us, we haven't found a good way to reconcile these two. Okay, maybe that's a way you can think about. You have two scripts, both are true, but when you put them together, it may not be true. Okay, because signature change or whatever. So,
yes, thanks.
So,
I just got it.
Yeah, great question. But hopefully, I give you the high-level idea why,
Yes,
the ordinals is very compatible, because ordinals, it doesn't affect the script. If it's true, you put ordinals in, it's still true. If it's false, you put it in scripting, it's still false. So it doesn't change the semantic of the contract itself. Okay, and a bunch of other reasons, stable, scalable, and also interoperable. These are the a subset of what even in the ecosystem. Even though Ordinal just came out like earlier this year, versus some of the tokens which has been around forever, and it gains a lot of support. Got all the services and different players. They all support this, and of course I talk about it's not in Bitcoin SV. Pretty much is when you talk about Bitcoin tokens, people now assume it's just ordinals because it gains a lot of popularity even outside of Bitcoin SV. Okay.
In this chapter, we will focus on tokenization. Once you use the script, you can tokenize everything.